Hi everyone, my name is Danielle and I will be talking about benzocaine synthesis for the lab abstract that was written for organic chemistry, the first series, in the series. So let's just get started. Benzocaine was first synthesized by German scientist Edward Ritzert in 1900 in the search to find a non-addictive alternative to cocaine. Benzocaine is a derivative from p-Aminobenzoic acid, or PABA, and is a weak topical anesthetic primarily used in products such as sunscreen, oral anesthetics, gels, lozenges, ointments, solutions, and sprays. Benzocaine does not suffuse well into tissue and is not water-soluble and is therefore not used for injection due to its molecular structure. The compound lacks the crucial tertiary amino acid that is necessary to enhance the solubility of the compounds in the injection solvent, which is generally HCl. Generally, the synthesis of benzocaine is a two-step process, but for the purposes of the experiment performed, the first step of p-nitrobenzoic acid being converted into p-aminobenzoic acid, or PABA, was skipped, and the procedure started with solid PABA rather than p-nitrobenzoic acid. In order to synthesize benzoic acid for PABA, a Fischer esterification reaction is required. Fischer esterification is the esterification of a carboxylic acid by heating it with an alcohol in the presence of a strong acid as the catalyst. In the experiment performed, ethanol, 95% VV, was used as the alcohol. Acetic acid, or what I used was distilled white vinegar, was used for the strong acid catalyst, and the solution was then buffered with sodium bicarbonate or baking soda to raise the pH to roughly 8.0 before cooling, and then decanting the liquid and ending with the crude synthesized benzocaine. The desired product, crude synthesized benzocaine, was obtained in the second attempt of the experiment. In the first attempt, vodka 50V over V was used as the alcohol rather than the ethanol. During the heating process in the first attempt, a Ziploc bag was not used to further trap the heat, and the lid for the container was removed too soon in the process due to the buildup of pressure in the container. These errors resulted in the solution not reaching the desired temperature, which ultimately caused the experiment to fail. The benzocaine was not produced. In the second attempt, these sources of error were addressed. Ethanol was used rather than vodka, and the container of the solution was placed in a Ziploc bag, and then the lid remained on the container until the buildup of pressure caused it to come off. After that happened, the lid was left on with a small crack to let the gas escape, and the Ziploc bag was opened slightly as well to help release some of that pressure, but also help to make sure that the heat was obtained. During the second attempt, the color of a solution was checked by removing it from the microwave rather than checking it inside of the microwave, because the light from the microwave could have an impact on getting an accurate read on what that color was. This helped to verify the desired temperature was achieved. Ultimately, after making the necessary adjustments in the second attempt, crude benzocaine was synthesized, and the experiment was successful. It was determined that the substance was benzocaine by testing a small amount on the surface of the experimenter's skin, which resulted in a faint numbing sensation that lasted for a few hours, which corresponds to the effects of benzocaine. In conclusion, benzocaine is a weak topical anesthetic that can be synthesized from p-aminobenzoic acid in your case. The at-home experiment that I described shows that benzocaine can be synthesized fairly easily and is therefore an accessible drug. Thanks so much for listening in, and I hope that you found this informative.